So thanks for having me. I'm Justin Butler, and I'm representing the Chegg mobile team in San Francisco. And me and my teammate Ose in the back with the Chegg shirt are here visiting our counterparts in the Chegg Israel office, and we're just doing a bit of a knowledge exchange and kicking off a new project and stuff like that. Aviel told me about the meetup and said, do you want to present? And it sounded like a cool idea. And then he said, oh yeah, there might be like 100 people there, and oh yeah, we're going to film it and we're going to put it on YouTube afterwards and stuff like that. So now I'm straight off the plane, feeling a little jet lagged. So if I start mumbling and nothing makes sense, it's purely because I have a lack of sleep and not because I don't know what I'm talking about. So yeah, Chegg is in a really interesting state right now. I don't know, I'm actually not sure like what context you guys have leading into this presentation, but Chegg is in a really interesting place right now where it's developing a lot of new digital services for students, and so we are building a lot of new products sort of from the ground up. So it's really exciting to be there on the engineering team because you're not coming in and saying like, okay, this is this. I mean, it is a very established company, but you're not coming in and saying like, oh, there's all this legacy code that you have to deal with. You have to conform to the patterns that we've developed thus far. It's sort of like coming to the table and saying, okay, we want to build XYZ out for students. Like, what is the best thing right now? What's the framework of the week, or what do we want to try out to see if it's the best thing? And there's so many projects across web and mobile, whether it's mobile web or Android, iOS, or the full web stack. There's a lot of cool things going on, and basically every team is taking a step back to be like, okay, what is the freshest, newest stuff that we can implement so that in a few months when we have new hires, we can say, oh, this is the legacy code that you have to conform to because we made these decisions when you weren't here. Hopefully they're the good ones. And so one of those decisions that we made when we were building the Chegg Tutors app was to use ReactiveCocoa. And Aviel asked me to come and talk a little bit about ReactiveCocoa and our usage in the Chegg Tutors app, not only to their team, but to you guys as well, and just answer some of the questions about it. Chegg Tutors, just so that you know, I might reference it a lot, it's the portion of Chegg that allows you to get in contact with somebody who teaches a subject, and you can sort of set up, you can message with them and set up scheduling like a lesson. We have like an interactive lesson space online where you can sort of Skype, it's like a video conference where they can have a code editor that you guys can both share, or a drawing board, or a text editor, things like that. So the app is at this point largely about messaging and scheduling functionality. So to start, just kind of focus on what is ReactiveCocoa, and some of you guys may already be familiar with it. I was talking to somebody earlier who had already used it for several months, building a real-time app, and this might be a little bit of a review, but it's hard to focus on some of the interesting aspects of ReactiveCocoa if you don't have the background. So I guess the very basic thing that you can say is that ReactiveCocoa is a framework to bring the functional reactive programming paradigm to Objective-C. It obviously sits on top of Cocoa, which makes it slightly different from the sort of reactive extensions that came from .NET, which was a heavy inspiration for these guys. Josh Abernathy and Justin Summers from GitHub, when they were making the Mac client, the Mac GitHub client, this was what spun out of that. So it's easy to sort of fall into like a rabbit hole of asking a lot of questions about the reactive paradigm. So I'm going to try to keep it pretty shallow, but the very next obvious question when you ask what is ReactiveCocoa is, okay, then what's functional reactive programming? The next step from there is sort of to say like, okay, well, what is the difference between sort of the normal imperative programming paradigm and the functional programming paradigm. And I'm taking a cue from Mike Taylor's blog here to point out this XKCD comic where Cue Ball is getting really frustrated because somebody keeps trying to describe directions to a place, and he just keeps saying, oh, well, if you give me the address, I can just figure out what I'm supposed to do. And this is a pretty good way to illustrate the differences between something that's functional and something that's imperative. Imperative is basically saying really directly, like, exactly how to achieve the results. So it's step by step. It borrows from the sort of fetch and process philosophy that CPU takes, where it's like, oh, this is the first step, and then you take a left, and then take a right, and you're finally going to end up at your destination. But the functional paradigm says we should just be much more declarative. The whole point of functional programming is to be declarative. Just say what you want the result to be, and everything else, the behavior sort of stems from that. And so it's sort of like giving the location for the address is what you actually want to happen. And the idea behind programming in this way is that you don't have to make the gap between saying, like, okay, I'm going to provide the computer with these instructions, but will that end up in the result that I want to achieve? Because we all know when we're programming, it's like, what we want to achieve is that the button turns red and then you click on it and something displays. But the steps to get there, especially with a framework like Cocoa, can be pretty convoluted, and then you have to do all this bookkeeping and figure out, is that actually what's going to happen? So one of the most common, maybe overused examples between the difference of the two is like calculating a factorial. So in the empirical or imperative programming, you would say something like, okay, give me a number as an input, and I'll have a counter, and I'm going to subtract one from the counter and multiply, and then have a for loop where I subtract one from the counter and multiply the result, and then return that at the end. Whereas the functional programming methodology would be to say that the function definition is essentially to take the input and multiply it by that function definition with the number -1 as an input. And we can all quickly realize that that's a recursive methodology, and actually recursion is like a huge topic in the functional paradigm, whereby you're essentially, the function definition is what you want. It's saying exactly what you want at the end. In that regard, FRP and ReactiveCocoa can be kind of hard to wrap your head around in the beginning, but it has a lot of added benefits, and so getting over that speed bump allows you to do a lot of cool things. So what does that all mean in terms of like usefulness to us? Well, imperative programming was pretty easy back in the day when a lot of the programs were sort of command line. It didn't take a lot of inputs. Like whatever your input was, it's processing, and spit out the output. But computing has evolved like quite a bit. Where at this point with like the iPhone 6, there's so many different ways that you can interact with it. You run into these situations where you're having to do asynchronous request processes like networking. You've got this mess of like callbacks, and you're handling touch movements, you're handling signals, and so because of that, the old imperative programming style is really clunky, and you actually end up with much more code than is required if you go the functional route. And so that's why ReactiveCocoa is something that we really want to use when we're programming for Cocoa. Okay, so what is at the basis of ReactiveCocoa? Everything is about data on a signal. It's streams of bits of data. And this is like a really stereotypical diagram. You'll see this if you go to reactive extensions. There's all kinds of diagrams that explain. This is about the base class is a rack stream. And that simply just is an abstraction of bits of data on a signal. So RACSequence it breaks the two subclasses are RACSequence and RACSignal. RACSequence is a poll-driven stream, and the idea there is that collections are missing. Collections in Foundation framework are missing a lot of the higher order functions like merge and filter and map, and this is basically providing you with those things, but it's lazy. It processes things lazily so that there's a lot of performance gains that you can get depending on what you're trying to do. But the real meat of ReactiveCocoa is in the RACSignal, which is push-driven, so that the data types that you're sending over the subscription can be anything that you want. And so you get in this place where your view controller is subscribing to the data that it wants to deliver or manipulate or something like that, and it becomes a lot more flexible. So like, for example, here is what a RACSequence might offer you. Here's an example where we're filtering and then mapping an input from an array that's just a bunch of words, and the filter says only give me the words that are greater than 10 characters in length, and then after you get that word, I want it to be all lowercase. And so that would be kind of difficult using the collections offered by Foundation, where it can be pretty streamlined here, but it's not. This isn't too fancy. What's fancy is that you can use all of these higher order operators on sequences of any kind of data, whether it's things that are coming from your server or stuff that's happening on the UI. Here's just like a broad example of some of the things that are available through ReactiveCocoa, and you can see it's a lot of categories on some of the stuff that you're really familiar with on Cocoa. So almost anything can become a signal, a push-driven signal. If you have a button, it's very easy to just access the property that's the signal for touch events. Like same thing here for gesture recognizer, controls, collections, image pickers. Those are a lot of the UI elements, but it's basically applicable to anything that you'll find in Cocoa. And an example that I'll give you is if we have a signal from each of the text fields that we have in this sign-up form, essentially what we can do is bind the reduced value of the signal to the enabled property of this button. And what happens is we use this operator combine latest, which says anytime I get a signal from any of these fields, I want to take the last signal that all of them gave, and I want to reduce the values inputted here in this block by saying, okay, we're going to check that the email wasn't nothing, the password is greater than 8 is our constraint, and that the passwords in the verify field match, and we'll return true false, and that will dictate whether or not the button's enabled. And this is something that really helps to make things more declarative. So this is just one. You can imagine that if you were trying to do this in the traditional way, you would have a situation where you've got all kinds of properties that you're keeping track of. I can't think of how many times before ReactiveCocoa that I would have a function whose return type was a bool, where I was basically just calling that function every time I needed to check whether a condition was true or not, and it would then access properties that had been set asynchronously by other processes. It's helping you in situations where you need to respond to asynchronous or data-driven signals, where you need to parallelize independent work where you need to sort of chain dependencies, or when you need to subscribe to things. So basically, whenever you need the UI to be listening to something, which is usually the case. So what are we doing within the Chegg Tutors app? This is just a couple of screenshots showing like a tutor's profile. We're doing two main things with ReactiveCocoa. There's obviously a lot of aspects, and we haven't even fully yet utilized everything that's available. But the first big thing is data binding. So we have an MVVM structure with our view controller. So we have a view model and then a view controller, and we actually bind a lot of the data that is distributed through the view controller to properties on our model, and I'll show you a little bit about that. And then we've also started to develop something called ReactiveREST, which is hopefully a library that we can open source at some point, but it provides some layers of abstraction for networking model whereby you're polling every once in a while to replicate a schema that's in your RESTful, I guess, JSON response down to the models that you mimic in core data. So I'll talk a little bit about how we did that. So with the MVVM data binding, we have a lot of view controllers that look something like this. So we will override init with coder to instantiate a view model instance, and then all the properties of the view model end up getting bound in view.did_load to a lot of the UI elements that are properties in the view controller. So, for example, we're just creating two labels here, and we're using the rack channel to assign the text of these labels to their corresponding NS strings in the view model, so that whenever the view model decides that something's going to update, the text just changes on the UI automatically for us. A lot of the magic of ReactiveCocoa happens through KVO, and it can be kind of a mess to deal with the syntax and the callbacks and the chaining that have to happen if you're worrying about the layer all the way down from networking through the persistence layer and back up through your view. This sort of does a lot of it for you, and it keeps things really simple. Just a few lines to make sure that things update. It also works really well, like I was saying before, for chaining dependencies. So here's an example where we're trying to set the picture for the placeholder, and what we do, again, this is really declarative. We're saying that we're going to observe the signal coming from the view model's user, and the data that's going to be pushed onto that stream is going to be user objects. And when we get that user object in a next event on next, we will create an avatar for the user, which is something that we can do with the user data in memory. In the actual app, it's like a logo, kind of like Gmail with a big capital letter. But we're going to start the process of downloading their profile picture from the URL that's associated with that user. And this dependency chain says, okay, like when you get the update for the user, the first thing you want to do is set this image, but after that, start this new process for asynchronously fetching that image, caching it, and when it's completed, or when the signal sends on complete, this block is going to evaluate set needs display so that the picture updates and everything funnels back up through. So as you can see, like, we don't have to do anything where we're setting extra properties, and we have a semaphore to make sure that, like, if we are trying to pull the avatar image from the cache for performance reasons, that by the time that's set, that we didn't already get a callback from the networking layer to set the image, because then we run into a situation where we've set the actual profile image and then overridden it with the avatar image because of a timing issue. So the other side of the equation is essentially the ReactiveREST component, and this is sort of a diagram of the mentality behind it. But we have a data model where essentially we're persisting the objects and their relationships through core data on the client side, so that we can be optimized for offline usage and stuff like that. But what that means is that often the UI has to kick off some kind of event that says, okay, the user clicked on this button, go fetch that data from the server, bring it all the way down to the persistence layer, and then I'll hear about it later. And it's a huge cycle that would be really difficult to manage unless we were chaining the signals along, and that's sort of the idea here. So we have, at the very core of things is AF networking, and then we use a lot of subclasses and extensions categories from CL Toolkit. I think it was written by Tony Shao of Collections Labs. It's a pretty cool library. It's there's not a lot of documentation, and it's kind of a grab bag, but it's basically subclassing a lot of common objects that with a signal implementation where it's applicable. And then on top of that, we've created the ReactiveREST API, where we're taking the signal from the HTTP client and converting it to something where we know what the response type is going to be and forwarding along the appropriate data type along the signal. So the signal moves across through a cache for performance reasons, and then this is really one of the big meaty parts of ReactiveREST, which is the property mapper, and that's sort of the bridge between the core data models and what gets returned by the server. And we essentially have a DSL language that's borrows a lot from Mantle. Mantle was also written by the guys on the Mac client for GitHub, but it allows us to say, okay, this property on this kind of object gets mapped to this field on this core NS-managed object, and when it comes through, we can save it down, and then that object gets passed along through the signal back to this interface where the operation was kicked off. So everything is contained in this reactive operation, which sits on top of CL operation. That's again from CL Toolkit, but that's a subclass of NS operation. So it's using the operation queues, and what happens is that throughout the app, we'll use our ReactiveREST singleton to enqueue these requests that are essentially CL operations that have signals for their state, like which part of the processing they're on, so that the signal that gets sent through the API, through the cache, through the mapper, up from the persisted object back to the UI is exactly what the UI is looking for. It's a really good abstraction layer. Everything in the view controller is essentially saying, like, I would like to subscribe to a signal that gives me users. I want to know about your progress, but I don't care about anything else. And that's sort of what we hope to achieve. I think I sort of have an example of what the property mapper looks like for our NS managed object subclass. This is our user. We have some routes that essentially say this is where you can go on the server to get these things. But our DSL has this mappings class that takes this block of all of the things that we want to map from the REST fields to the attributes on our NS managed object. And we also handle all different kinds of relationships, so one-to-one, one-to-many, many-to-one. And at the end of the day, things are getting persisted even without the view controller being aware of whether that needs to happen or not, because an instance of the object in memory is getting passed back on the signal. So the UI is happy, and it can go about its business. It's a lot less code. It's much more declarative, and it's worked out pretty good for us. Here's an example of something that comes, essentially for free with all of this implementation, which is our pull to refresh. So pull to refresh is an extension on the table view, which has a fetch results controller as a data source. And basically, the subscription is made on the fetch results controller's delegate methods for on did change content. And so as things are persistent in core data, whatever the predicate was will realize that something new has been persisted by ReactiveREST. And the delegate is going to get called for on did change content, which sends that user object in memory up through, or I guess in this case, a notification, up through the subscription. And then the part of the UI that's waiting for the notification to come back, which is currently displaying a loading thing, will get a next signal that says, here's a new notification. Do whatever you need to do to clean up the UI at this point. And that's just, I suppose that's one area where we use it in one of its most beneficial forms. So that's basically all I had to say, in addition to this sort of obligatory hiring slide. So we are hiring mobile developers in Tel Aviv and in San Francisco. So if you're interested in architecting cool projects from the ground up, you can check out our listings or just contact me later. And I'm definitely happy to answer questions, though I can't guarantee I'm going to have an answer for everything.
Some place you used RACSequence 2.
Yes.
And some other place you use RACobserve. Like, why are you using RACSequence 2 if you are not doing two-way bindings?
So in those cases, it is a two-way binding, and there's certain things that can happen where we want to make sure that if a signal comes up with the new data, that it doesn't necessarily overwrite something that we set explicitly in the view controller, which is why we use the channel as opposed to an observe. But you're right that we usually do use observe.
ReactiveCocoa for a thing, like something that connects with Bluetooth or anything like that? Just listen to the stream?
No, we haven't. And I mean, even more real-time implementation. I mean, this is where it really shines, and maybe you should talk to this guy later because his app is real-time. He is using sockets for updates, which is where we want to go in the future. But that's where the real meat of this comes in, is when you actually have a live stream that you're trying to send to the UI. So there's added challenges with that, but we're not yet doing anything where we're integrating with different parts of the hardware, and so we haven't gotten a chance to handle it. Okay.
Any threading issues? Doesn't matter.
No, it's fine because you can specify the scheduler that you want this signal to use, and so it happens on both ends. You can say, I want this subscription to occur on a particular scheduler, whether it's, you can use the main thread, but you can say, like, I want this to use a thread pool, or I want it to use a new thread that it generates, or you can specify where you want the observation to happen. So you can say, you can do this work on a separate thread, but I want the signals to come back on the main thread, which is most often the case, at least in our implementation. But you can also say, I want the signals to occur on a separate thread, which is sort of like our polling engine says something like, okay, subscribe on a thread from the scheduling pool so that whenever the networking request comes back, you can just persist that without us knowing about it, and we'll get the signal that is observed on the main thread from the delegate methods of the fetch results controller, and that's what will update the UI. So yeah, it's actually really convenient in that way. All right, well, feel free to ask me questions later. I'll be hanging around.